All right, so this week we're going to cover a couple of fundamental concepts in web development that really don't directly apply to building a web app, right? Up to this point, we basically said, here's how you build a web app. We've kind of skimmed over a lot of the concepts, giving you the fundamentals, but not talking about nitty-gritty. And the reason for that is because the nitty-gritty could take probably an entire term by itself. When I took this, or actually I didn't take this course. This course didn't exist when I was in this program. When I was in this program, there was a course that was just about IIS. And the course took, at the time we did 10-week terms because we did quarters. It took an entire quarter just to cover IIS functionality. Not web development functionality, not building any web apps. We were serving up HTML pages in IIS and talking about how to configure it. So when we dive in here, and it's changed obviously in the last 10 years. So when you come in here today, there's a whole lot of stuff. So what I'm going to focus on for part of this part of the lecture is going to be SSL certificates. And even then, I'm not going to get into everything because there's so much that you can really dive into. But I'm going to give you enough so if someone says to you, hey, can you SSLize my server? You can go, yeah, I think with a little bit of Googling, I can figure that out and be familiar with the terminology and what your objective is, okay? I also want to hit some of the highlights that are in IIS just so, again, you're familiar with stuff. So if someone blindsides you and says, hey, can you do this thing? You can go, yeah, I think I can do that, okay? So the first thing, before we get into the specifics, I want to kind of just give you the lay of the land. So I'm actually clicking on the IIS host itself up here in the upper left-hand corner, and the icons I'm seeing are the different sections of functionality for IIS. So IIS has two primary units of logic, I guess you could say, two logical spaces. Looking at the left-hand side, we've got application pools, and then we have sites. So this is a default install of Windows 10 with IIS. Pretty much all your servers look about the same. Your application pools, I like to think of them as isolated processes that I can run my websites under. So when I say isolated process, what that means is if you ever pull up your task manager, and you look at each one of these little guys here, or even better if you go to the details view and you look at all these, each one of these lines here is a process. So when I host a website under one of these app pools, this app pool becomes one of those little guys, one of those processes that's listed under my task manager. Now, you could build 10 websites and run them all under one process, and that's perfectly fine. IIS will allow you to do that. It'll do resource pooling and put all of those resources under that single process. Now, what happens if one of those 10 websites goes haywire and sucks up all your CPU cycles? Well, the other 9 websites suffer big time because they're all being processed under the same resource pool. So instead, what you can do is, and by default, your default website goes under your default app pool. And there's all these pre-configured ones that are in here. Now, they don't run until a request is made to the web server by default. So what you can do is if you're hosting multiple websites under a single server, you can actually add additional app pools. And for your ASP.NET MVC apps, you'll want to make sure that you're running .NET CLR version 4 in integrated pipeline mode. Okay. Now, that was the basic setup for an app pool. There's a lot more functionality under advanced settings. I won't go into all the details, but things to consider. Depending on your app and how it runs, you may want to enable or disable 32-bit mode on that pool. So basically, you can have an app pool that runs in 32-bit mode versus 64-bit mode. If you start dealing with specific types of database drivers, they may only function in one of those two modes. So you may have to force your app. If you're running on a 64-bit machine, it'll run in 64-bit mode by default. If your app requires 32-bit mode, then you have to go in and enable your app pool to run in 32-bit mode. Otherwise, your app will run, it'll go to connect to a driver, and it'll come back and say the driver is either incompatible or does not exist. And that's because the driver is 32-bit, the app is 64. Has anyone ever covered 64-bit versus 32-bit? Do you guys understand that concept well enough? Okay. So you run into those. Those are very real things. You can put limits on the amount of percent a particular pool uses. So you can do resource isolation and limiting. You can pick which processors. If you're in a large infrastructure with lots of CPUs, you can actually isolate how many CPUs or how many threads each app pool has. You can do start mode on demand or always running. That has to do with, does your app start up immediately when the server starts up? Does that app pool thread, that process start up? Or does it not happen until the first request comes in? And I'll talk a little bit about that later and what that means. What identity or what user does your app pool run under? And that can make a big difference depending on if you're accessing file system resources or network-based resources. You want your application to be able to access a file on a share on a server somewhere else within your network. We have to make sure that the app process is running as the right user, because whatever that app is running as, it takes on your permissions. So permissions become an important factor to consider. There's timeouts. How long does the process run? If it's idle where nobody makes a request, after 20 minutes, that IIS will actually kill the process. It'll shut it down. And that's just to release more resources back to the overall server. There's orphaning. There's rapid fail protection. So if you're having a case where your application is not responding well, it keeps throwing 500 server errors, it will actually, IIS will detect that and shut the process down, trying to protect the server from issues. Virtual machine limits, recycling, so actually do you want it to spin up a new process and all requests get transferred over to that new process and it'll shut down an old one. So if you have a memory leak, let's say, if your app starts consuming more and more memory, do you actually want to have it shut down one process or spin up a new one, push everyone onto that new process thread, and then shut down the old one to release the memory? So you have that type of options as well. So that's the Reader's Digest version. So we have our app pool. And then under websites, we actually have our actual websites. Now these sites, if we go under advanced settings, you'll see where these are pointed. So the default website actually lives at system drive, which for me is c/inetpub/www root. So that's where, if I put an HTML document, that's where it gets served from. We can change that to be whatever path we want. We can point it to another drive, another folder, whatever we want. The protocols, limits, a lot of these again are just different settings that you have. This does not control what port or host name your website runs under, though. This is just the site itself. To make those changes, you actually have to go and look at the bindings, and we'll come back to the bindings in a little bit. But basically here, we're running HTTP on port 80 for any IP address on this server. All right. So what does that look like from a browser standpoint? We jump into the browser. So the browser assumes that all your HTTP traffic runs on port 80. That's actually the port that's designated for HTTP or web traffic. So when you navigate to localhost, you're actually navigating to localhost port 80. So that thread's getting spun up, and then this HTML page is being served by that app pool. So if we jump back into the task manager, we go to details. Your processes run as W3, WP when they're running under IIS. And those are called, W3 is www, WP is worker process. So in the earlier versions of IIS, IIS had three main pieces of functionality. There's the World Wide Web Publishing Service, the FTP Server Service, and SMTP Relay Service. So the W3 harks back to the World Wide Web Publishing Service, but they now call it the W3 worker process. So it runs as W3 wp.exe. The user it runs as is default app pool, because that's the name of the app pool. So what I like to do is whenever I'm deploying multiple apps or multiple sites on the same server, I will make the app pool name the name of the project. Is this like a game? So I do that so that way I can quickly sort everything and figure out which process is which app. And if I have one that's running out of control, then I know, okay, I need to go back and look at some code in this app, or at least I know who's the culprit, instead of them all just showing up as IIS user. So if I kill this, and then let me bring this over here, and it's now going to, oh, let me go back, and let me do refresh on here. Oh, that happened a lot faster that time. Let me kill it again. And I'm going to refresh the page again, and you'll see what happens is there's a bit of a pause, and then that process pops up and running. So it's actually launching the process or the app pool on demand. All right. So if we want to add a new site, we can right-click, say Add Website. We can give the site whatever we want to call it. It will actually generate an app pool for us by default. So you don't have to create the app pool first. It will do that for you. Or I can come in here and select an existing app pool, which I already created. And I'll just use my app pool that I created. We pick a physical path for hosting it. I'm not sure what's on my E drive, so we'll call it website. And then we can do test settings, authentication, path through authentication. We don't have any authorization, so we can't verify anything. So right now we've got HTTP for all unassigned IPs on port 80. So that'll basically say any web request that comes to the server will get sent to our web app or our website. The catch here is that we already have the default one running. So I'm going to uncheck the box that says Start Website immediately because I'm going to turn off the default. So we'll hit OK. It's warning about the binding. So I'm going to go ahead and stop by right-clicking. Actually, you can't do that anymore. You click on it, you come over to the right-hand side, and you say Stop, and that'll stop the default site. We'll come over here and then start our website. Now our website doesn't have anything inside of it. So I'll go ahead, I'll just put a document in here for the time being. So now if we navigate to localhost, what's up with that? Okay, I thought it was cached. Control F5 clears the cache. So that's now my Hello World page coming from my E drive. So if I jump back to my process or my task manager, go to details, jump down to W3, you'll now see that there's actually two worker processes running. One is that default app pool, which has a website that's stopped. That thread or process will spin for 20 minutes until it realizes that the actual website's down, it's not getting any more requests, and it'll kill that process. It spun up a new process for my WSAD15 site, so now I have a secondary process running that's taking up 12 meg, that's basically serving up one HTML page. There's a way to turn off a lot of the background stuff so you can limit the amount of memory use on a process depending on the type of content you're serving up, but that's beyond the scope of the course. But there are ways that you can tune your apps or your app pool so that they only take up the least amount of memory necessary. All right, so that's all well and good. We got our site up and configured. So we've got a whole bunch of different options for our website. We can manipulate .NET functionality, and that whole top section of .NET stuff is basically, it's a nice GUI front end for managing your web config. So you can go in and manage connection strings, providers, pages and controllers, application settings, .NET users, session state, roles, profiles, SMTP email, all of those settings that you can manage are in your web config. You can also manage them here. The idea in everyone's mind is that your people who host your website don't know how to write code. So instead of letting them modify the web config, we're going to give them a nice little GUI that'll parse the web config for them and then manipulate those changes. From my personal experience, if you write code, you should know how to stand it up on a server and host it. I'm not saying that you should be an expert at it, but you should be able to spin up an IIS server and get your code running. Fair enough? All right. Now, IIS itself has its own settings, including authentication, compression, default document, error pages, handler mappings, redirects, HTTP response, SAPI filters, MIME types, modules, output caching, request filtering, SSL, and WebDAV. The ones that I would recommend taking note of out of all of them are probably in this order: authentication, compression, handler mappings, modules, SSL, output caching, and error pages. And that's not necessarily perfect, but that's what we're going to do. And the reason I say that is that you're always going to want to manipulate and customize it for your authentication routines. If you're building a web app that has a login page, you want to make sure your authentication is in place. Compression is a big thing that sometimes is not turned on or even installed by default, but compression can give your website about a 10-fold increase in speed if you just enable compression. And all that means is that the web server will take every request, and when it responds back, it will gzip compress it before it sends it across the wire. So if you've ever taken a 10 meg file and you've done a basic zip file compression on it, you can take it from 10 megs probably down to about 1. Just straight text. And what's your HTML documents? Straight text. JavaScript, straight text. CSS, straight text. So they're just pushing text files across the wire. You get pretty good compression. So enabling compression makes a big difference. The default document is what document gets served up when the page request happens. When you get into ASP.NET MVC and there's some other components in there, it doesn't make a big difference, but HTML page serving makes a difference. HTML handler mappings are the next big thing, because that actually says when this type of request comes in, this is the component that handles it. And that's important when you're running higher level things like ASP.NET MVC, Node, things like that, because you don't want IIS just to do a straight HTML static page serve. Modules falls into that same category. SSL, obviously if you're configuring SSL, that's important. Output caching, you can actually set it up that certain page requests don't even make it all the way into the server process. IIS itself has an output cache that says when this request comes in, instead of going to the disk, instead of running a process, just serve that content right back to the client. So you save yourself round trips, it takes a little bit more memory, but it gives you better performance on the app. And then the request filtering kind of puts you in that same boat. And the error pages is, do you want a pretty page response, or do you want kind of the ugly red and yellow page of death response? A lot of that's gotten taken over by ASP.NET MVC's kind of internal workings. It'll serve up good error pages instead of giving you the ugly ones. So it's really kind of your decision where you want to handle it, or if you want to handle it in both places. Either option is valid. All right. So that's the kind of a basic rundown of IIS. All right. So just kind of get yourself familiar with it. Aside from deploying a website and getting things configured, you're not going to spend a ton of time in this space. Once you do it, It kind of becomes like riding a bike. Once you're in it, you're going to be living in it for a period of time, and then once you're done, you're not going to be in it again. But then when you come back to it, it'll start to feel familiar again. So the first time, it's always the hardest. First time I stood up a site on IIS, it took me probably the better part of the day to get it set up, because I ran into differences between the server and the client that I was, or the server and my dev machine that I was working with. So I had to research this error, figure out what I needed to change in IIS on the server to make sure that it matched up, or modifications that I had to make because of the version of IIS on my machine versus what's on the server. So it's typically the biggest headache you run into, and that's when you start dealing with these handler mappings as to which mapping is handling what, and sometimes you have to remove mappings in order to get things to stop colliding. So.